In the triangle pictured below, find x and y. Well, as you can see, you have 3 right triangles, so you can use proportions for similarity in which to find what y and x is. I'm going to start off with y. So the first proportion I'm going to set up is 12 over y is equal to y over 4. We get y squared is equal to 48. Take the square root of both sides in order to get y by itself. 48 breaks down to 16 times 3. 16 is a perfect square. 3 is a prime number, so y is equal to 4 radical 3. And in order to find x, we need to find or combine the 12 and the 4 in order to get the whole entire length of the hypotenuse of the biggest triangle, or the biggest right triangle here. So that's 16. So it's 16 over x is equal to x over the part that it's attached to, which is 12. X squared is equal to 16 times 12, which is 192. Take the square root of both sides in order to get x by itself. That breaks down to 64 times 3. 64 is the perfect square. So x is in fact equal to 8 radical 3. According to this, there's another method that can be used to find x and y, and that's called the Pythagorean's theorem. So we're going to find the lengths of the missing sides using this theorem, or this formula instead. Okay, so which two triangles share angle B? That's going to be triangles ABC, the larger triangle, and triangles CDB. So write a proportion that compares these two triangles using the ratio longer leg to hypotenuse, then perform cross products. Okay, so the longer leg of the larger triangle is A, meaning little a, and the hypotenuse is little c. I'm going to put that over the smaller triangle, longer side is x over 2 hypotenuse of a. Okay, so the cross products would be a squared is equal to x times c. And the two triangles that share angle A are triangle ABC and CDA. Okay, so now we want to represent it shorter leg to hypotenuse. So the shorter leg of the larger triangle ABC is B. To the hypotenuse of C, little c that is. And then shorter leg of the smaller triangle is Y to the hypotenuse of B. Cross multiply, B squared is equal to YC. the same picture. We're going to separate the small, medium, and large triangles, label each triangle with the appropriate vertex and side labels. Okay, so for the small triangle, for the large triangle, the corresponding sides are CB is the more upright, and A is down below. And for the medium triangle, as you can see, we have the corresponding angles in the same spots. For A and for B in between all similar right triangles. So now we can find the same values for y and x using Pythagorean's theorem. So I'm going to focus on this little triangle here. So we have two sides. Across from the right angle is the hypotenuse. And that's equal to the sum of the squares of the legs. And y squared. So the hypotenuse square is equal to leg square 4 plus the other leg square y. And then we just solve. So we take the square root of both sides. This breaks down to perfect square of 16 times 3. We get 4 radical 3 is equal to y, which is just like what we got on the original slide that is using proportions, similarity proportions. Okay, so now I'm going to find the value of x, and I'm going to need the length of this whole entire side, which is 16. So 8 square plus x square is equal to hypotenuse square of 16 square. 64 plus x square is equal to 256. Subtract 64 from both sides in order to isolate x squared. You get 192. Take the square root of both sides. This breaks down to perfect square of 64 times 3. Simplify to 8 radical 3, which is the same exact value that we got using proportions for similar triangles on the first slide. So we're asked to find the missing sides to the nearest 10. I'm going to label this with an X, and I'm going to label this with an X. Those are both the legs of a right triangle, so I'm going to set it up as leg square plus leg square is equal to hypotenuse square. Same thing over here, 14 squares leg square plus leg square is equal to hypotenuse square. Reverse the process of squaring the number, so we get x by itself. That's equal to 40. So the length of the third missing side is equal to 40. They asked us to round to the nearest tens place, so we should put 40.0. Okay, so 14 squares equal to 196 plus x squared. 21 squares equal to 441. We're going to subtract 196 from 441. In which we get 245. Take the square root of both sides to get x by itself. Take the square root of 245 in your calculator and you're going to get 15.7 as your final result. Because you're asked to round to the tens place. Okay, so now we have some application word problems. Tanya runs diagonally across a rectangular field that has a length of 40 yards. So I'm going to highlight rectangular and I'm actually going to draw that picture because I'm a very visual person. And she has a length of 40 yards and a width of 30 yards. What is the length of the diagonal in yards that Tanya runs? So with a rectangle, we have all four angles as right angles, and if we draw a diagonal, we end up with two right triangles. Okay, so we're looking for our hypotenuse because that's across from the right angle here. That's always the longest side of a right triangle. We're going to set it up as leg square plus leg square is equal to our hypotenuse square, labeled as x. So 1600 plus 900 is equal to x squared. 2500 is equal to x squared. Take the square root of both sides, get x by itself, and the square root of 2500, that's a perfect square, is 50. So the length of the diagonal that Tanya runs is 50 yards. Okay, so the sides of a triangle are 7, 11, and 18. Do these sides form a right triangle? Justify your answer. So we're going to substitute this into Pythagorean's theorem and check and see. So I know these two are the legs because the hypotenuse is always the longest side. So that's going to be my value for C. So is 7 squared plus 11 squared equal to 18 squared? And we just do the math. So it's 49 plus 121 equal to 324. And as you can see, 170 is not, in fact, equal to 324. And as a result, these sides do not form a right triangle. Because if they did, they would work out in Pythagorean's theorem. So in order to justify my answer, or in order to justify your answer, because they do not prove in either write Pythagorean's theorem or a squared plus b squared equals c squared if you can't remember that. Your assignment at this time is to complete the associated homework that goes along with this lesson.